My name is Peter West with West Networks. I'm SD-WAN cellular, really specializing in cellular mobile connectivity. And with me, I've got Chris Talbert with MobileMark. We've been working together for years and years. It's kind of fun to put a face to the name and be able to talk live with you like this and be able to answer some questions that a lot of people ask, especially when they're trying to connect mobily. And with this work from home growing so much and first responder networks growing so much, the idea of reliable, stable communications is important. And, Peplink, obviously, we provide the router technology that we like to do with the cellular bonding. But then we have antennas that we need to connect those cellular networks. And that's where Chris and MobileMark come into play. And I'm actually going to hand this over to Chris and let him talk. And then I'm going to kind of throw in some sports commentary notes as he's talking and interrupt him just so that I can get clarification. So I am monitoring the chat. So if you have a question that you'd like to ask Chris, please chat with me and I'll interrupt him and we'll get some questions answered as well. So I'm going to hand this over to Chris and he can share his screen and take over. So thank you, Chris, very much.
So again, thanks Peter for having me on with this webinar. Excited to see kind of where this new webinar series that you've been working on is going. Definitely enjoyed the last one that you had, and excited to see where it goes. So again, my name is Chris Talbert. I'm with MobileMark. I'm a regional account manager. I've been working with Peter, like he said, for a number of years now. Kind of utilizing our antenna solutions for his Peplink router installs. We are a U.S.-based antenna design and manufacturer. We're located in Itasca, Illinois, which is just right outside Chicago. We can actually see O'Hare Airport from our window. We design, manufacture all of our antennas out of our Itasca, Illinois facility. And we do have a facility in the UK as well, where we, for both sales and manufacture to the European Union. The rest of the world we kind of cover out of our Itasca, Illinois facility. So some of the topics that Peter and I came up with that we wanted to go over is basic antenna theory and practice. Kind of what is the terminology that we use in the antenna business? What do they mean, and how can they be applied to practical real world applications? They're going to go into a lot of different styles of antenna solutions that we offer, some of the key markets that we operate in, some of our featured antenna installations supplied by West Networks, as well, and finish up with a Peplink matchup highlights for some of the more popular Peplink routers, and then of course leave it open for some conclusion and questions. So basic antenna theory and practice. So a lot of the terminology that we use in the antenna business, it is very technical, but it has a lot of real world applications, and it does mean something. So a lot of times you'll see words like transmit and receive. Transmit is the radio frequency signal carried through the coax from the radio that you're transmitting out of into space. So that is the radio frequency, the energy from the radio that's being transmitted out. Then there's the receive. That's the energy that's collected by the antenna through the electromagnetic waves, and then travels back through the coax to your radio. Then there's frequency. Frequency is a very simple term. It's defined by the number of cycles per wave, which is defined as hertz. And then the bandwidth, which is a lot more applicable to real world, is the frequency ranges utilized by any particular service within that frequency range. So a lot of times you'll hear things like band 71, which is the hot 5G T-Mobile bandwidth right now, and that just refers to the bandwidth from 617 to 698 megahertz. So that's the bandwidth, and the bandwidth is within the frequency. Another very important part of when we're designing antennas is what's called, we refer to it as VSWR, which stands for voltage standing wave ratio. And what this is the energy, because whenever you transmit something out to the antenna, not all that energy is actually going out the antenna. Some of it is actually being kicked back towards the radio, and that's the voltage standing wave ratio. And so what we really shoot for when we're designing an antenna is to keep that below a 2-to-1 ratio. So we want a lot more energy going out of the antenna than what's being kicked back towards the radio, because Anybody that's been dealing with radios for any specific amount of time knows that, you know, a lot of times you'll get things like feedback, you'll get reduced power, and that has to do with the energy. A lot of that has to do with the energy that's being kicked back. So when we design our antennas, we really look for a 2-to-1 ratio to minimize those problems caused by the energy kickback. Another really big part of antenna, both design and practical real-world applications, is the gain. The gain just has to do with how the energy outside leaving an antenna is focused. So there's a couple different types of gain that you'll see depending on who's building the antenna, who's specing it in. There's isotropic and dipole. This just has to do with the way the gain is calculated. But we're really, for real world applications, what you're really looking for in gain is what does the radiation pattern leaving the antenna look like? So in a ideal world, you have, in a zero gain world, you'll have a perfect sphere around the antenna, which means the radiation is being transmitted equally or along a perfect sphere of the antenna. As you increase gain, you start to flatten that energy that's leaving the antenna, and you are focusing the energy in a specific direction. The benefit of something like this is that you can, with the same amount of power, you can get a further distance. The downside is that anything that's below or above the horizon of that energy pattern won't be able to communicate with your system. So when you're picking an antenna, the gain is a very important thing to look at because depending on how you are doing the installation, what the application is, gain can either be a really good friend or it can be an enemy. So again, that's a very important part of when you're picking an antenna to look at the gain and see how that relates to where your installation is going to be in space. So again, how you pick an antenna, which antenna you pick is going to be determined by a number of different factors. Big one is, where is the antenna being placed? What is it going to be placed on? Is it going to be placed on a fixed structure? Is it going to be on a vehicle? Those are some very important questions to answer, when you're going to pick an antenna solution. In cases of, buildings or infrastructure, you often want to place it as high as possible. In cases of buildings and infrastructure, you can also utilize a high gain antenna since it's not moving. It's a fixed site and you can point it exactly to where you need it to go. Another thing to take into account is the orientation. How is the antenna going to be installed? It's going to be installed upside down. It's going to be installed vertically, horizontally. How you install the antenna is also going to determine, what kind of antenna you're going to need. Two of the big types of antennas that we sell are the omnidirectional and directional antennas. An omnidirectional antenna just means that the radiation it radiates from the antenna pretty much on a 360-degree angle. So around the entire antenna is where the radiation is going to be directed. And on a directional antenna, you focus the energy in a much more specific direction, which is where you would want to utilize things like in cases of infrastructure and building. If it's a fixed location, a lot of times a directional antenna would be a good solution because you can direct the energy to a specific location and improve your reception that way. Another very important part of picking the right antenna is, along with the where you're going to be placing, is how far away from the radio the antenna is going to be. As you increase cable length, you're going to decrease your gain. You're going to decrease the amount of power that's going to the antenna. So as you increase your cable length, you really need to take into account the type of cable that's being used. Other different types of cables are good at longer distances than some types. So we actually have come up with a tool. We provided the tool to West Networks to be able to utilize in picking the best antenna for a solution. So the amount of loss that it occurs in any cable run is determined by not only the cable length, but the frequency at which you're going to be operating. Those two factors you take those two factors into account to pick the best type of cable for your solution. So again, making sure that you understand where the antenna is in relationship to the radio, how far away they are from each other, the frequency ranges you're going to be utilizing for that solution will help you determine the best type of cable for your installation. Next, I want to go into a lot of the different antenna styles and solutions that we offer here at MobileMark. We have covert antennas. These are designed to generally inside vehicles where you have got a clear, a window view available to the outside. We've got both single band, multi-band antennas available in covert style, embedded style. They can often be used inside of a plastic enclosure. We've got infrastructure antennas, both directional and omnidirectional antennas, as well as fixed site for remote monitoring, networking, and so forth. We've got multi-band antennas, the LTM-WG, or GW, it's actually WG, I apologize for the mistype here. 944 series, this is our wideband 6 to 6 4x4 MIMO antenna available for mobile applications, as well as our Y42700 WB. This is another wideband antenna, MIMO directional antenna, high gain antenna designed for infrastructure and infrastructure applications. Some of the key markets that we operate in. First responders. We've been involved with first responders for a long time. We have both LMR, which is the low frequency radios, frequency ranges for existing infrastructure. We've got FirstNet. We've got Wi-Fi, LTE solutions for first responders. For the LMR feature, we've got a low profile antenna that we just developed, which is a relatively wideband antenna for first responder applications. We've got one that goes from 145 to 161 megahertz, another one from 162 to 172. So at these frequency ranges, that is quite a wide bandwidth. And for a low profile antenna, which is just a few inches tall, that is becoming a very popular model for us. We also have Yagi antennas, directional antennas, base station antennas for these applications as well. I touched upon FirstNet earlier. FirstNet, with AT&T coming out with their FirstNet products, we have a lot of different antennas available for these applications. We've got a lot of mobile antennas. We've got a few infrastructure antennas available that can be utilized for FirstNet applications. A lot of our FirstNet antennas are designed for vehicle use, in which case they're a lot of times combined with other cellular, 5G, LTE, Wi-Fi, and GLONASS GPS elements as well. Covers, like I said, very wide range from 600 megahertz up to 6 gigahertz for pretty much all your LTE, FirstNet, 5G bands, as well as Wi-Fi and GPS. Some of our more popular antennas for the FirstNet is our SMWG412. This is a single. This would be a single element for the FirstNet, as well as we have applications or elements for Wi-Fi and GPS in here as well. We've got our LTM series, which are MIMO. So if you're looking for FirstNet MIMO capabilities, we've got our LTM series available for that. We also have infrastructure antennas like our DoD7 700, 2700, which would be great high gain antenna for a building utilizing FirstNet. Public transportation. This is as public transit has been increasing over the past few years. We've been kind of on the forefront in getting solutions available for public transportation. We've got a lot of different antenna solutions for public transportation. All of our antennas are router agnostic, so regardless of the router manufacturer, we have antenna solutions for it. We really are our claim to fame really is the ability to customize antenna solutions. So regardless of the antenna that's being used, how it's going to be installed, where it's going to be installed, we've got antenna solutions configurations available for that. Really big on Wi-Fi connections for vehicles inside, outside buses, which is becoming more and more popular as customers are looking for a very seamless data experience while they're going from point A to point B. 5G ready. This is when I first joined MobileMark, this was the big thing. And this was one of the things that really made me excited about joining this company. Since it was became kind of become in the public eye that 5G was coming, MobileMark's been involved with leading the charge and getting a lot of different products available that are 5G ready. When 5G was first being developed a few years ago, there was a lot of question marks in the world as to what, where it was going to operate, what it was going to do, what would be the applications, and so forth. So what MobileMark decided to focus on really is the low to mid band frequency ranges for 5G. So the 600 megahertz to 6,000 megahertz range. So we call it 6 to 6. That is where we're really operating. I know a lot of 5G is operating on millimeter wave bands as well. We've kind of decided from a very early on not to really do anything with that, just because of the nature of millimeter band waves. It just really isn't going to where we wanted to operate. We really wanted to operate on the mobile applications, infrastructure applications for the low to mid band. So we've got a lot of different antenna solutions for all these low to mid band ranges. Some of our feature.
I'm going to interrupt real fast. Let's talk about millimeter wave just a little bit more, because this is something that comes up a ton. And I think there's a misconception related to that. And I like the fact that MobileMark even a long time ago saw that it's just not something that is viable in mobile scenarios, or at least even worth your business model. And so it opens up a bigger discussion for me when I'm talking to my customers about millimeter wave and 5G. And I know that for us, a huge focus is in that 6 to 6 or the sub 6 5G range. But I'd love to hear, if you don't mind, if you have the technical capability to add why we can't do millimeter wave reliably in mobile. Because I know that there's, from a salesman's perspective on the routers and or from AT&T and T-Mobile, they want to say, we have 5G, we have all this connectivity and it's capable. But there's a big difference between 5G millimeter wave and 5G sub 6, and why in a mobile world should we stay away from the millimeter wave, or at least in MobileMark's opinion?
Right, and that's a very complex question, but the simple answer is because millimeter waves do not travel well, they are not good for very long distances. That's why they're primarily focused on urban areas for these frequencies, is because they really need to have a tower every couple blocks in order to make it work, and it takes very little to block that signal. A leaf, some rain can really do damage to the millimeter wave signals. Now, in cases where they're putting up the infrastructure, and pretty much all the carriers are doing a pretty good job right now getting the infrastructure up in those urban areas to be able to provide that really, really fast, high G, low latency experience to customers. One of the downsides and why we really didn't get involved with that is because of the nature of millimeter waves. We have to have the radio pretty much right on top of the antenna.
Okay.
So the radios are integrated with the antennas. Yeah. We focus on, like I said before, being router agnostic. So we're not partnering with any particular router to create an antenna just for that router, and we're not designing our antennas to be built with the radio. So that's not, again, kind of going back to what our capabilities are and what they're not. But because we're really focused on the mobile applications and site applications, it just didn't make a lot of
And
it was just too difficult.
And that's actually where I was getting at, because it's where I personally feel, but it's nice to hear from somebody else that same thing, and then to be able to have kind of almost kind of a uniform concept for that. Because when you're talking about mobile operations, a vehicle, a bus, an RV, a mobile health clinic, an ambulance, et cetera, first responder vehicle, the idea of millimeter wave being able to travel around with a vehicle is highly unlikely that that's going to be available for those applications. The way I see the millimeter wave being applicable is in fixed wireless solutions where you have like a customer provide, CPE connected to the side of a building aiming at a tower, and they have that millimeter wave connectivity providing that multi-gig throughput. Would that be is that fair assessment? That
is a very fair assessment, yes.
Okay, you can move on. I just wanted to have that conversation a little bit there, just because it's a huge hot point.
It is a huge hot point, and it's something that we discuss here a lot. We've had the discussion internally, and we have them with our customers all the time regarding the millimeter bandwidth, and and kind of where we fall within that. So again, we have a lot of different antenna solutions. We've got a single element 5G ready antenna. We've got 2x2 MIMO, 4x4 MIMO 5G ready 6-to-6 antennas available. We've got infrastructure antennas available. A very large product line, and it's increasing on every couple of months. We're coming out with new products for this market. Kind of what Peter was just talking to a little bit ago is the private LTE networks. CBRS, the FCC allocated quite a bit of spectrum for private LTE networks, which can utilize 5G protocols as well. And we carry a number of different antenna lines and solutions for private LTE networks. And they're actually very similar to the product lines that we saw for 5G. We've got single element 2x2 MIMO, 4x4 MIMO available. We've got vehicle infrastructure available for these private LTE networks that are available. And again, it's an ever-growing product line that we have available for this. And I want to thank West Networks for sharing some of these installation pictures with us for some of the installation options. West Networks is really involved with our 2x2 and 4x4 MIMO LTE line of antennas. He's been utilizing that for a number of years now, and it's great to see these LinkedIn posts and these LinkedIn photos with our antenna solutions available. So maybe Peter, if you can look at the first picture with the LTMG series that are on that EMS.
So most of what we're doing, and kind of left to right, it's kind of a funny one because that LTMG that's there for that EMS, we're connecting into an HD4, which we'll talk about when we go into and a lot of what we do with healthcare is providing stable connectivity when you're out in the field. So as cellular is variable and connectivity is variable, being able to utilize 4x4 MIMO or 2x2 MIMO, depending on the router with the multiple antennas, gives us the ability to provide the end users incredible reliability. So that EMS solutions, an HD4 with most likely that's a Cat 12 HD4 MBX, and then on the right, I'm going to leave the middle one alone, but on the right, that's actually powering an EPX. That's a 15 cellular solution. And with the LTMG 940, we're able to do, because it's 4x4 MIMO and it's 2 antennas per modem at a Cat 12. So we're actually able to do 2 modems per antenna, providing that 15 antenna solution, cellular solution, allowing live mobile mammography and radiology capabilities out in the field. So it's really neat. And that middle one, that's kind of funny you guys picked that one, but that was an RV that we installed, and it was I can't say it was fun, but I did my best. So don't judge me.
So again, some other antenna installation pictures here. The one on the far right there, the Technobus, that was one that really excited me, and I was hoping maybe Peter, you could talk a little bit more about that, because I'm really excited when I see our antenna solutions being utilized for basically a public service like this library is utilizing it for.
There was actually a really fun install too, because this library, a lot of times when you're providing a public service, the standard solution, we'll just grab a hotspot, we'll plug it into a USB port, provide Wi-Fi, boom, the end users are connected, and it's not. And this library system really, in my opinion, took the next step. I mean, that's actually being powered by, once again, an MBX Cat 12 device, And it's an old bus. You can see it's one of that round roof. It's almost like a converted school bus. And so it wasn't that easy to install. So we had to use mag mount antennas. We found a junction port that we were able to push through, manipulating one of the existing installs, and then kind of like fed through that cable down the existing wiring. So it was kind of an interesting upgrade. But they provide, they have inside that vehicle, they have a whole bunch of computer stations, and then we provide exterior and interior Wi-Fi. So they can pull up and kids are able to do their schoolwork or connect, get online with either provided computers or bring their own computers and join on the Wi-Fi. And so, you know, it's an incredible community service that this group is providing. And they like this so much that they're actually building another one that we're going to be pushing out next year. So Q1 of 2021.
That is really cool and really exciting.
And on the left, oh, sorry.
All right, I will go back.
The left actually perfectly correlates to that LTMG install that was for the mobile MAMO. You can see all those SMA connections right there, and just the sheer number of modems that we have. And that it's so fast. it's just so fast. And so, anyways, that's all I had.
All right. So, kind of going into what, let's say a little bit of a segue here in just a peppling matchup. So another tool that we've been developing and working on for years is what we call our matchup guide, just to help make the antenna choice a little bit simpler. We've got it available for most router manufacturers out there. You know, kind of the more popular routers that are out there for the different manufacturers, and what the best antenna solutions are for each individual router. So if we go into, like, you know, for maybe the first one here, which is, you know, the Max HD2 Mini, you know, which has 4 LTE ports and then of course the GPS GLONASS port. You know, you can go through our guide and pick out a number of different antenna solutions that will work for this one router. So if we just take a look at this one router, we've got 4 antenna solutions available for it. And, you know, we've got our LTM G940, which has 4 LTE and of course the GPS. We've got a 2 antenna solution with our low profile 302 and a 202, and we're able to kind of customize the antenna configuration based on the individual routers. One thing on this one that we're really excited about is our LTB series of antennas. These are a very thin profile antenna designed for utility boxes. Nice thing about this is it's very ground plane independent, so it can be mounted very easily on a NEMA box, whether it be you know, a fiberglass box, a metal box, a plastic box, whatever the material is. It's an easy installation for it, and because it is ground plane independent, you don't need to worry about, you know, having that ground plane to mount it on, as well as having that low profile available for make installation really easy for a number of different applications, and along with our fleet antennas for like our LTM Max Fin and our LLP low profile series. Another of the coupling routers is the Max BR1 Pro, and again, this is a 2 LTE GPS and 2 Wi-Fi and router, and so we've got a number of different single antenna solutions available for this, whether it be our LTM series, our Max Fin series, or our low profile LLP series. We've got an antenna solution for that, which is just the 2 LTE, 2 Wi-Fi, and of course the GPS GLONASS. And because our antennas are customizable, we are able to configure them with, you know, whatever cable length you need, with whatever connector is needed. In this case, you know, the SMA connectors for the peplink. Another real popular peplink model is the Max HD2 LTEA. This is a 4 LTE, 4 Wi-Fi, GPS GLONASS router, and we've got a couple different antenna solutions for this one. You know, we've got the ability to utilize our LTMW G944 antenna, which is 4 LTE, 4 Wi-Fi, and of course the GPS. But depending on the application and where it's going to be mounted, we've got, you know, like I said, a number of different antenna solutions. This is, you know, one application that we see a lot of is buses, you know, going back to public transportation that we were talking about, where, you know, public transportation companies are looking to be able to provide a Wi-Fi service to their passengers while going from point A to point B. The LTM G944 has the 4 LTE, 4 Wi-Fi, and GPS bands all located on top of the bus. So if you're looking to provide, Wi-Fi solution to people on the interior of the bus, the Wi-Fi on the LTM 944 really isn't going to penetrate and get inside for a good customer experience. So we've got separate antennas available for that. So something that's becoming, that we're seeing a lot of right now is utilizing our LTM WG940, which is a 4 LTE and GPS, and then utilizing an interior antenna like our NXD antenna for the Wi-Fi for the people inside the bus. A lot of times what they're doing is they're putting this pretty much dead center inside the bus, providing a very uniform Wi-Fi experience for all the customers or all the passengers inside the bus, which can be a much better experience for the passengers compared to having maybe a stub antenna or rubber duck antenna by the router, which is often located either the front or the back of the bus. We're also seeing this in some train applications as well.
That's a neat. I like that Wi-Fi idea. We have to put that on our next vehicle. And actually learned that during this webinar, so that was kind of fun.
Yeah, and we're really excited about this new NXD antenna because it is a 4x4 Wi-Fi antenna, but it's very low profile. It is very, very thin profile.
So we'd mount that upside down in the vehicle, then come in and plug into the MBX or the HD2.
Exactly. And kind of going back to we're discussing with the cable runs. Depending on the cable run, we determine the type of cable that's being used. And we have, we're able to build, jumper cables with whatever kind of cable you need. So that way, regardless of how long the cable run is, you're not going to lose that signal. You're not going to lose any gain.
Speaking of that, the custom cables real fast, how long, what's the going lead time on custom cable lengths? If a customer says, hey, I need to be 3.5 feet or whatever, I mean, how long does that take? Because I know we keep 15 feet and 30 feet in stock, but
depending on the cable type and the cable length, it's anywhere between 1 to 2 weeks.
Okay, so it's not that bad.
For some application, for some maybe like a really, really, really long cable run where you need a couple hundred feet of say LMR 600, that might be a 3-week lead time.
Okay,
because we're able to manufacture everything here, out of our facility. We don't have to worry about importing anything from overseas. We're able to do everything in house here. It's just a matter of building it.
Okay, yeah, that's great.
So the Max HD2 MBX Cat 18. Again, we've got a 2 antenna solution for this, which is our LTM WG944, LTM W940. The LTM WG944 will have the 4 LTE, 4 Wi-Fi, and of course your GPS. And then the 940 will have the 4 LTE. Same thing. We could potentially do a 3 antenna solution if you're looking to provide Wi-Fi, say on the interior of a vehicle. You could do 2 LTM 940s and then an NXD Wi-Fi antenna on the interior. Again, we've got a lot of customizable solutions, and anybody that's done installs for any particular amount of time know that unfortunately it's not always a one-size-fits-all solution. Now we start getting into the Cadillacs here. So the Max, and I know you want to talk about these. So the Max HD4 MBX, the Cat 12. This is of course the 8 LTE. Or actually, no, it goes up to 12 LTE.
That's actually the MBX Cat 18. So because it's 2, and then you have 4 and 4, so you have your 8. So it's a MBX Cat 18.
Yeah. So this is the Cat 12. So this is the 8, and then we've got our Cat 18, and that's where you got up to 12 LTE.
There you go. Yeah. Now you got now you have 16, right? 4, 4, 4, 4. Because 4x4 modems. 4x4 MIMO, so 16 cables plus 1 for the GPS.
Right. And then of course you got additional cables for the Wi-Fi as well.
And then on the front. So if somebody wanted to do the external Wi-Fi, we'd have to do QMA for the cellular and then SMA for the Wi-Fi. So we'd want to custom order that cable, like a 944 QMA SMA.
Right. Yeah. So, I mean, a lot of times, I know you guys have been getting the QMAs quite a bit lately, utilizing the QMA for the LTE and the GPS. And then, of course, if you want to come in the front with the Wi-Fi, utilizing an NXD solution for that, we can build that with our I believe it's the reverse polarity SMAs for that.
Yep. Yeah, so that would be a great matchup there, is that the 940s a QMA, and then the NXG. Is that, am I saying that right?
NXD.
NXD.
Or NDX.
I got you backed up now. NDX,
yeah.
for the Wi-Fi.
Yeah. And that might actually be a good thing to maybe potentially add on to this as well, because
I think we should just add that NDX on there.
Yeah, because we are seeing more and more of these type of solutions where they're looking to separate the Wi-Fi antenna for internal customer use.
Perfect. And I think we're ready for.
With that, we're ready for questions.
Okay. I do have one question, and I don't know if it's good, if it's appropriate for this, or Daniel, we might talk about it a little bit a little bit off topic here, but Daniel did ask us if he's interested in how about the high bandwidth, low latency connections for real-time communications. But one of the things is that, latency and bandwidth really, and at least my experience, it comes in that carrier diversity. And then one of the things that Peplink provides is our WAN smoothing technology that allows you to kind of like get that lowest latency connection. But it would be neat to see on an antenna side of it how to optimize or maximize the capability. Because you mentioned about the bubble and the gain, and then the amplification and location. So is there an antenna choice that would help lower latency and increase bandwidth? And 4G?
From my experience, and from my experience, it really isn't so much an antenna choice as what is maybe an increase in the number of inputs or elements, or going from the 4x4 to a 8x8 MIMO. And it seems to be a much bigger influence on latency than specifically the bandwidth.
Yeah, that makes sense. And then, do we have any other questions or any comments or feedback, or is there anything more that you'd like to hear about what you already heard about? And Daniel, please, we'll reach out separately and talk about that. There's a lot we can go into that. That's probably a whole nother conversation.
That's probably a whole other webinar.
Yeah, it's a whole nother webinar. Exactly. Lowering the latency. It's something that I'm passionate about and definitely can go into, but want to make sure that we address the antenna topic per se on this portion of it. And so I'll give it just a couple more seconds if anybody has any questions and would like to ask. Otherwise, I'm going to say thank you so much, Chris, for giving us this education. And I actually learned a little bit about some of your antenna choices here, just training for this webinar. Because primarily for us, it's been the LTM antennas. That's our kind of go-to antenna, just with our mobile applications on the vehicles. So to learn about how your other antennas are applicable with the zero ground plane and stuff, I'm already, kind of churning about how we can utilize those in some different IoT applications, especially with cameras and those plastic NEMA boxes and things like that. And so, and I think we actually talked about that a couple of weeks ago. So, and so we have those capabilities and options now. So, but otherwise, I'm not getting any questions. So we either did a really, really good job or a not so good job. So wait, hold on. I missed some of the beginning. If you discussed directional antennas for permanent home install, I'd love to hear something about how that works.
So I mean, we did address some directional antennas for infrastructure solutions. I didn't necessarily go into a home install application for that. I know that our Y42700 X2 is being utilized for a lot of DAS systems for apartment complexes, so that could fairly easily be transferred to a home application. For somebody that's looking to provide internet access to their home, it'd be a directional antenna that you can install, a 2x2 MIMO solution that can then be pointed towards the tower that you're trying to hit and provide reliable, consistent signal.
So if you do want to get specific antennas, Eric, if you email us sales@westnetworks.com, we can put you in contact with Chris and get that right antenna for your home install, and just matching it up to the router to make sure we got the right number of connections and the distance and length of the cables. But yeah, I was going to say a directional panel mount antenna or some variant thereof, or even a Yagi, if you know where the antenna, the tower is. I actually did a project. It's for, what is that? It's huge, CES, back in 2017. And we used an HD4 with 4 Yagi antennas, and we aimed them at the mountaintops far away. So that, because you got 300,000 people all sucking up all the cellular bandwidth of all the towers locally, and we were getting 400 megabits of throughput using the Yagi antennas mounted, going far distance away. So worked out really well for us with LMR 400 cable. So there is definitely options and capabilities, especially in a fixed environment, Eric. There's pretty much unlimited opportunity to get that cellular connectivity if you're willing to mount something to the side of your house. Thank you so much, Chris, for your time, and thank you for this this education. We're gonna and thank you everybody for joining in and watching. And if you have any feedback, once again, you can email us, sales@westnetworks.com, or reach out to me on LinkedIn, or reach out to Chris on LinkedIn. I tagged him on the post. So, but otherwise, thank you so much, and thank you, Chris. Have a great day.
Thank you, Peter.